Welcome back to the Awesome Agents podcast. Today we're looking at something most people never think about when they talk to ChatGPT.
Yeah, how does the voice actually travel? OpenAI published an engineering post this week that gets into the real details.
900 million weekly active users. That is an enormous number of voice sessions to keep running in real time.
And voice has no slack. Text you can batch or queue. Audio has to be there in milliseconds or it feels broken.
They're using WebRTC for this, which I associate more with video calls in a browser. Why WebRTC?
It handles the hard stuff, NAT traversal, encrypted transport, codec negotiation. Rather than reinvent all of that, OpenAI built on Pion, an open source Go implementation of WebRTC.
And they hired the person who created Pion, and one of the original WebRTC architects from Google.
Sean Du Bois and Justin Newberti, both at OpenAI now. That detail in the post isn't casual name dropping.
So what was the problem with their original approach?
Port exhaustion. Standard WebRTC allocates one UDP port per session. At that scale, you need tens of thousands of public ports exposed on Kubernetes.
And load balancers aren't built for managing huge UDP port ranges.
Kubernetes makes it worse. Pods reschedule constantly. You can't require each pod to hold a stable large port range when it might disappear in minutes.
So what did they build instead?
Two separate services, a stateless relay that handles all the public UDP traffic, and a stateful transceiver that owns the actual session.
Walk me through the relay, because I think that's where the interesting design is.
The relay just forwards packets. It doesn't decrypt anything, doesn't run protocol state. The client sees one fixed IP and port. The relay reads just enough of the first packet to know where to send it.
And how does it figure out where to route without some big external lookup service?
They encode routing metadata directly into the ICE username fragment. That's a field in the WebRTC handshake that normally just looks like a random credential string.
So they're hiding a routing address inside a standard WebRTC field.
Right, and the client has no idea. The relay reads it and knows exactly which transceiver owns that session. No extra round trip on the critical path.
That is a genuinely clever design. What does the transceiver actually do?
It owns everything. ICE state, the DTLS encryption keys, the full WebRTC session lifecycle, backend inference services connect to it over simpler internal protocols.
So the model itself doesn't need to know anything about WebRTC.
Exactly. The model just receives audio. And they also did some smart Go level tuning on the relay to handle the load.
Like what specifically?
There's a Linux socket option that lets multiple Go routines share one UDP port, so the kernel distributes incoming packets across them, and they pin each Go routine to an OS thread.
So packets from the same session tend to land on the same CPU core.
Better cache behavior, less context switching. And they stayed with standard user space Go the whole time, no kernel bypass frameworks.
Meaning careful Go code handled global real-time media traffic without reaching for the more complex tooling.
That is the claim, and they published enough detail that you can evaluate it yourself. I find that refreshing.
What are the real trade-offs here?
Every packet takes an extra hop through the relay before hitting the transceiver. For voice that adds latency, sub 300 milliseconds end-to-end is roughly where it starts feeling conversational.
And they use Cloudflare to steer users to a nearby relay first, so the public internet leg stays short.
Right. Media enters OpenAI's network close to the user, but it's still one more hop than a direct path, and the post doesn't publish latency numbers for the relay leg itself.
What does this architecture not handle well?
Multi-party. If you want a human agent to join a live session, or multiple users in the same voice room, this pattern isn't built for that. It's one user, one model, low latency.
So the practical takeaway for developers building on the real-time API today?
Use WebRTC, not WebSockets. OpenAI has specifically optimized this entire infrastructure stack for WebRTC. If you're seeing inconsistent latency, geographic relay coverage is part of what determines your first hop cost.
Makes sense. And the fact that they published this level of detail is useful for anyone trying to understand what they're actually building on top of.
More engineering posts like this, please.
Agreed. Thanks for listening to the Awesome Agents podcast. We'll see you next time.